Today, we'll be solving LeetCode 695, max area of island. In this problem, we are given a two-dimensional grid where each cell is either land, represented by the number 1, or water, represented by the number 0. An island is a group of connected land cells, where cells are connected horizontally or vertically but not diagonally. The task is to find the size of the largest island, where the size is simply the number of land cells that make up that island. If there are no islands at all, we return 0. Let's think about the approach. We'll need to go through every cell in the grid and check if it is land. If it is land, we'll start exploring that island and calculate its area. To explore an island, we can use depth-first search, also known as DFS. Each time we visit a land cell, we will mark it as water so we don't count it again, and we'll increase our current island's area count. After finishing the DFS for that island, we'll compare its size to the largest size we have found so far and update our maximum area if needed. Now, let's break down the code step by step so everything is clear. We start by defining a function called max area of island that takes in the grid. The first thing we do is get the number of rows by saying rows equals length of grid, and the number of columns by saying cols equals length of grid at 0. These will help us keep track of our position in the grid. Next, we define a helper function called DFS that takes two arguments, R and C, representing the row and column of the current cell. Inside DFS, the very first step is to check whether R is less than 0 or C is less than 0 or R is greater than or equal to rows or C is greater than or equal to cols or grid at R and C is equal to 0. If any of these are true, we immediately return 0 because it means we are either outside the grid or we have hit water or already visited land. If none of those conditions are true, that means we are standing on unvisited land. So, we mark it as visited by setting grid at R and C equal to 0. This prevents us from counting the same cell more than once. Then, we start calculating the area of this island. We begin with area equals 1, since we are currently on one land cell. After that, we explore all four directions. We say area plus equals DFS with our -1 and C to go up, then area plus equals DFS with our +1 and C to go down, then area plus equals DFS with R and C -1 to go left, and finally area plus equals DFS with R and C +1 to go right. Each of these DFS calls will return the size of the connected land in that direction, and we add it to our area count. Once we've explored in all four directions, we return the area value back to the caller. This completes the DFS function. Back in our main function, we create a variable called max_area and set it to 0. This will keep track of the largest island we have found so far. We then loop over each row by saying for R in range of rows, and inside that, we loop over each column by saying for C in range of COLS. If grid at R and C is equal to 1, we know we found land that hasn't been visited yet. So, we call DFS with R and C, which will return the size of that island. We then update our maximum area by saying max_area equals the maximum of max_area and the size we just found. After scanning the entire grid, max_area will hold the size of the largest island. So, we return max_area as our final answer. In terms of time complexity, this solution runs in O of m times n, where m is the number of rows and n is the number of columns, because each cell is visited at most once. The space complexity is O of m times n in the worst case due to the recursion stack when the island takes up the whole grid. And that's how you solve LeetCode 695, max area of island. Thank you for watching and let's keep learning.